Box and whisker plots. Here are our learning goals. First of all, we can identify and calculate the minimum, maximum, and quartiles, Q1, Q2, which is also the median, and Q3, along with the range and interquartile range of a data set. This will make more sense once you get the lesson. The second learning goal is to construct and interpret accurate box and whisker plots from a data set and use them to describe how data is distributed. And third, to use the mathematical 1.5 times the IQR fence rule to determine if a data set contains outliers and represent them correctly with an X on a graph. Here are some key terms that you should be familiar with. When we talk about a data set, we're referring to a collection of information or numbers, in our case it's usually numbers, that are grouped together. Central tendency is a way to find one single number that best represents a whole group of data. We've talked previously about mean and median and mode as measures of central tendency. Quartile are values that divide a list of numbers into 4 equal parts. Box plots, or box and whisker plots, are a type of graph that shows how a group of numbers is spread out. Dispersion describes how spread out the data points are. An outlier is a data value that is significantly larger or smaller than the other data values. And range is the difference between the smallest and greatest value. Just as a quick recap, let's look at how data can be visualized in various graphs and charts. Starting off with these two, they're kind of familiar in that we refer to those as pie charts or circle graphs. The next two here are variations of bar graphs. And this one, you might remember, is a pictograph. And this last one down here is a scatter plot. Previously, we've talked about measures of central tendency, so just a quick refresher. The one we're most familiar with is the mean, which we often refer to as the average. Basically, to get that, we add up all the values and divide them by the number of data values that we added. The next one we use quite often is the median. That's the middle value of the data. So in order to do that, we have to first order the data from smallest to largest, then choose the one that's right in the middle. And if there are two middle values, we have to take the average of those two values. And finally, there's the mode, which is the value that occurs most often in the data set. And in some cases, we can have more than one mode, so there can be a tie. So when should we use one central tendency over another? You hopefully recall that the mean is the best measure of central tendency to use when the data provided consists of numbers that are all relatively close to one another. The median is the best measure to use when the data provided consists of numbers that are relatively close to one another and the data contains outliers, so values that are much bigger or much smaller than the rest of the data. And finally, we use mode. It's the best measure for central tendency when the data provided represents frequency of choice. So far, we've been working with one variable datasets and performing statistical calculations on them. The data can also be displayed visually or graphically in the form of a box plot, also known as a box and whisker plot. Box plots allow us to easily see how the data is distributed, and this is a very simple version of a box and whisker plot. You can see where it gets its name. There's a box, and there are the whiskers. So what exactly is a box plot? A box plot is a graph that shows 5 key values from a data set. First of all, you get the minimum value. Secondly, you get the maximum value. You get the overall median, in other words, the Q2 or the second quartile. You get the Q1, which is the median of the lower quartile. And we get Q3, which is the median of the upper or third quartile. It looks like this when we lay those all out on the chart. So you've got your minimum and your maximum. Then you've got your first quartile and your third quartile, your second quartile, which is the median. And then you also have your interquartile range, which is the third quartile value minus the first quartile value. So what exactly is a quartile? If a dataset is divided into 4 equal parts, with each part containing 25% of the data, or 1/4 of the data, then each point in the dataset that divides these 4 quarters is known as a quartile. So you can see from this diagram, we've got 25% of the data here, 25% of the data here, and so on. So the data is broken up into 4 pieces, and each of those quartile markers represent the breaking points between each of those quarters. When we're making our box plot, it's going from the first quartile to the third quartile, and that's where we form the box. Let's look at an example here. The first question says, what is the lowest mark? So the lowest mark is going to be the minimum, and if we look at our chart there, we can see that it comes out at approximately 68%. Then it says, what is Q1? Well, that's our first quartile mark right there, and if we look closely, it's probably at about 78%. Then it says, what is the highest mark? Well, the highest mark is at the end of the other whisker, so in that case, it's probably about 98%. Then we're asked, what is Q3? And Q3 is right there, which is about 93%. And then what is the median? The median is right there in the middle, and that's at 85%. Now let's talk about the benefits of a box plot. When you have a box plot, you can easily identify the range, or you can easily calculate the range and the interquartile range. It enables researchers to quickly identify median values, the dispersion of the dataset, and any signs of skewness. Skewness is how much the dataset is sort of moved to one side or the other. You can see from these diagrams when the box plot sort of extends further out to one side, so when the median is closer to the Q3, that gives us a left skew. When the median is right in the middle of Q1 and Q3, then we say it's symmetric. And when the median is closest to Q1, then we say that it's right skewed, so it's got the long leg going out to the right. So the way I remember these as to which one is left or right skewed is I ask myself which one is the longer leg. So if the leg is the longer side going out from the median, so you get the median here, it's got a longer leg out that way than it does this way, that tells me it's a left skew. Conversely, here I've got a long right side on it, so that tells me I've got a right skew. So summarizing that, when the median is closer to Q1 and the whisker is longer on the right end of the box, the distribution is said to be right skewed or positively skewed. When the median is closer to Q3 and the whisker is shorter on the upper end, then the distribution is left skewed or negatively skewed. And finally, when the median is equal distance from Q1 and Q3 and the whiskers are roughly equal on each side, the distribution is symmetrical or has no skew. We often talk about the word statistics, but we've never really kind of defined that word. So statistics are any calculations that are made on a data set. IQR and range are two statistics that can easily be determined from a box plot. Range is the spread of the data set. So range is equal to the maximum value minus the minimum value in the data set. And finally, interquartile range is the range inside the box, approximately 50% of the data, and you calculate it from taking the third quartile and subtracting the first quartile. Range is the spread of the entire data set. The range is equal to the maximum value minus the minimum value. The interquartile range is a measure of statistical dispersion. It measures the spread of the middle 50% of the data. Your interquartile range, as we've said, is the third quartile minus the first quartile. It's not affected by extreme values, unlike the range. From this box plot, you can see here's the median, there's our Q1 and our Q3. And our Q1 is very close to the minimum, and our Q3 is very close to the maximum. So it's telling us we have a very high dispersion in our data set because that interquartile range is really spread out a lot. If it was much smaller, if our box was more like this, where that's our Q1 and that's our Q3, then we would have much less dispersion in our data. Let's do an example of reading from a box plot. Sometimes we have to do what's called interpolation, which means we're reading between the values that are actually graphed. So first we want to look for the minimum value. So it shows us there, and the minimum value falls at 4. Then we want to look for the maximum value. And so the maximum value is here at the other end of things, and that looks like 18. Then we want to find the median. And the median is by definition right in the middle of the data set. So that is at 11. Then we're looking for the range. So the range means we take the maximum value and we take the minimum value and we subtract the minimum from the maximum. That means we start off with 18 and subtract 4, which gives us a remainder of 14. We want to find the third quartile mark, and it looks like it's falling halfway in between 14 and 16. So we would guess that that is 15. And finally, the interquartile range. Whoops, no, we missed. I forgot about Q1. Q1 is equal to 6 because it's right there. And then finally, yes, we're going to calculate the interquartile range. So that's where we take the Q3 value and subtract the Q1 value. So we're taking our Q3 and subtracting our Q1. Take our Q3, subtract Q1. That means we've got 15 minus 6, which gives us 9. When you create a box plot by hand, there are a number of steps you have to complete. First, you have to order the data set from least to greatest or from smallest to largest in order to be able to find the median value. Then, you determine the median of the bottom half of your data. So you're finding the center of the bottom half of the data. So you're going from the minimum value up to, but not including, the median. This is Q1. Then you need to determine the median of the top half of your data, again, from but not including the median to the maximum value, and that gives you the Q3. Then you draw a dot at the minimum value and another at the maximum value. Then you draw vertical lines at Q1, the median, and Q3, and draw lines along the top and bottom to create the box. Then you extend a line from the middle of the rectangle to the max value and another line to the min value. So let's go ahead and take a look at doing that in the real world. Here's a set of data. Step 1 says we have to put everything in order. So let's do that. It looks like we start at... So I've got them in order. The next thing I need to do is find the median. The median is the centerpiece of data, but in this case, we've got an even number set of data. We've got 12 pieces of data. So that means we're going to end up, there's the median right in between 17 and 19, which conveniently is fairly easy to figure out. The median is going to be 18. So we can say we've got that done. Then we want the median of the bottom half. Again, we're falling where there is no exact number. So in this case, our Q1, so that's going to give us our Q1. And in this case now, it's going to be halfway between 8 and 10, which of course would be 9. Doing the same thing then for the median at the top. We want the median of the top set of data, top half of the data. And again, we're going to fall halfway in between 21 and 22. So that would be 21.5. Now we can actually start graphing out our box and whisker plot. So I've moved things around and added a number line so we can now add the box plot in. So the first thing we want to do is mark all of these things onto our number line. So first of all, let's find our median. Our median is at 18, so I'm going to draw a line there. Then we've got our median of the bottom, which is at 9. We've got our median of the top, which is at 21.5. Now we're going to put a dot at the lowest value, which is at 2, and a dot at the highest value, which is 34. Then we put a box around the median. That gives us our box. And we connect up the dots with whiskers. And that gives us our box plot. When we're doing our final version, we then mark on our key values, our Q1, our Q3, our max, and our min. And we've got our median, sometimes referred to as Q2. Now it's your turn. Try the homework.